Welcome to section 9.12. This is the 83rd session of the CISSP exam prep series. In this session, we'll work through embedded devices and cyber-physical systems. We'll answer several questions. What is an embedded system? What is a microcontroller? What is a static system? What are cyber-physical systems? Why do their built-in constraints create risk? And how do you actually secure this whole family? Why does this matter beyond the exam? Because these devices quietly run the physical world around you. Picture an elevator controller, a hospital infusion pump, and the check-in kiosk at an airport. Each is a small, fixed computer that touches real people and real machinery. When one of these fails or is tampered with, the harm is not just data loss. It can be physical. Learning to secure them protects both bytes and bodies. So what is an embedded system? It is a computing component added into an existing mechanical or electrical device to give it automation, remote control, or monitoring. It is designed around a narrow set of functions tied to the larger product it lives inside. Think of the tiny brain inside a washing machine or a smart doorbell. It is not a general computer. It exists to run one machine well. What is a microcontroller? It is a small, self-contained computer on a single chip. Simpler than a full system on a chip, but often part of one. It packs a processor, memory, storage, and input and output ports into one tiny package. Familiar examples include Raspberry Pi and Arduino boards. Picture a whole miniature computer shrunk onto something the size of a stamp, cheap enough to embed almost anywhere. What is a static system? It is an environment deliberately built to never change once it is set. The goal is to stop users and even administrators from making changes that could weaken security or break operation. Airport check-in kiosks, ATMs, and library guest computers are classic examples. When a session ends, the machine wipes everything and restores a clean, pristine state for the next person. One warning though, no system is ever truly static. A bug, a failed part, or an exploit can still shift it. What are cyber-physical systems? These are devices that use computation to control something in the real, physical world. If a device makes something move, it is acting like a robot. If it senses conditions like temperature or motion, it is acting like a sensor. Robotic surgery, collision avoidance in cars, and prosthetic limbs all fit here. The label puts the spotlight on the physical result, not the code behind it. That is why a breach here can cause real harm. Why do their built-in constraints create risk? Because these devices are stripped down to save cost and power, and that thinness eats into security. Limited power caps how much protection they can run, and pushing them can overheat and destroy them. Weak processors leave few cycles for security work. Many can barely handle encryption, sometimes relying on hard-coded keys. Some cannot be patched at all. Some have no real authentication, and some ship with baked-in credentials. And when you use one, you are quietly trusting the vendor and their cloud behind it. That trust may be misplaced. So how do you secure this whole family? You layer several controls, since no single one is enough. Segment the network, so these devices are penned off and an exploit cannot spread to them. Stack firewalls in series, from network appliances down to application and internal segmentation firewalls, so they complement each other. Group devices into security layers by sensitivity and use physical or logical isolation, even air gaps between levels. Apply firmware and software updates only manually after careful testing so no untested change slips in. Monitor everything for performance, violations, and compliance. This layered defense is your safeguard, because every single control has a flaw waiting to be found. So let's bring it together. An embedded system is a fixed brain built into a larger machine, often powered by a tiny microcontroller. A static system is locked to resist change and resets to a clean state, though nothing is ever perfectly static. Cyber-physical systems reach into the real world, which raises the stakes. Their cost-driven constraints, from weak processors to hard-coded keys, thin out their defenses. So you segment, layer firewalls, isolate by sensitivity, update manually, and monitor constantly. Defense in depth is what keeps these limited devices safe. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.